Hello everyone. Today we are going to discuss about RAG query enhancement techniques. So why do enhancement of queries in RAG? So it improves the retrieval accuracy and it overall reduces the hallucination and it improves the overall performance of the RAG system. So instead of using raw query from the user directly to retrieve the document, we can enhance the user query and which will give us better retrieval quality. So there are several techniques for query enhancement uh, like query optimization, metadata utilization, query transformation, query expansion, query pre-processing. So we will see different techniques in the next slides. So first comes the query pre-processing. It is like basic pre-processing of text. Like we can normalize the text, like convert it to lowercase, remove stop words. We can correct the spelling errors, remove unnecessary punctuation. We can apply intent recognition on the user query to better understand the user intent. Also, you can apply named entity recognition to better understand the user query and better understand the context of the user query. Next come the query expansion. So in query expansion, we expand the query by including synonyms or similar words or similar uh, contextually relevant sentences. So we can include synonym in the user query. Example, if user ask about AI, we can include artificial intelligence, machine learning, data science, those kind of terms to the query. And also you can add contextually relevant phrases to enhance the specificity of the query, and we can use word embeddings to identify and include semantically similar terms. For example, you can expand the best to top or leading or high performing. So you can include different kind of similar words to the user query based on the similar embeddings. Next comes the multi-query generation. So you can reformulate the original query into different multiple variations, so it captures the different aspects of user intent. So it will overall enhance the coverage of the relevant results, and it will be able to retrieve more relevant documents related to the user query. So sometimes it also helps us to be breaking down the ambiguous query into specific alternatives. So we can use any LLM to dynamically rewrite the queries, or we can use rule based approaches to rewrite the query into multi query. So for example, input query can be AI platforms, and the generated queries may be best AI platforms or startup, top AI platforms or developer, leading AI platform for research. So in this way it can cover different aspect of the AI platform, so more relevant documents will be retrieved. So there is another technique called query decomposition. So we break down complex query into smaller subqueries instead of using a single query. So it can handle multi-intent queries effectively, and it focuses subqueries on a specific aspect of the query. So it gives us comprehensive response. So instead of using the original query, we divide it into subqueries. For example, what are the AI best AI platform for startups and how do they differ in cost and features? So we can decompose this query into what are the best AI platforms for startups, what are the cost of this platform, what are the features of these AI platforms. So we can pass these queries separately and retrieve the relevant document and combine this all together and pass it to the LLM for a comprehensive response. There is another technique called step back prompting. So abstract and complex query is converted into broader and general question. We retrieve foundational information for better coverage. It refines the results to match the original query specifics, and it handles ambiguous or niche queries effectively. It improves the retrieval by broadening the search scope. So here is the example it has been given. So original query is related to a ideal gas. What happens when the pressure is temperature is increased by factor of 2 and the volume is increased by factor of 8. So you can enhance this query with the step back question like what are the physics principle behind this question. Then the LLM will answer in a better way. So it will answer the ideal gas law and also give us the explanation behind it, and in turn it will give us a better answer of the question. So instead of using a uh, complex query, we enhance it with a uh, broader or more general questions, which in turn enhances the retrieval quality. Then metadata filtering. So we use metadata like date, author, text to filter and refine our search results. So it we can focus retrieval on the most relevant and up to date and specific content using metadata. So it enhances the precision by excluding irrelevant documents. So instead of searching all through the database, we can focus on filtered relevant documents. So it reduces the response times also. So it also reduces noise in large scale or diverse datasets. For example, if user asks, did you implement any new policies in 2021? Then here in the user query, we can see that the year is mentioned. So we can use this year as a filter and filter out the all the documents related to year 2021. And instead of searching through all the database, we can search through the documents related to 2021 and then get the most relevant documents based on the user query. So this improves the overall search process, also reduces the response time and retrieval quality. So these were the different techniques of query enhancement to improve the retrieval quality in RAG. Thank you. Hope you have learned something today.